Good morning, Year 8. We are looking at aerobic respiration today. So your starter today is just have a little think. If there were two students running in the marathon, which one would do better? Would it be the one that has 3 bottles of Lucozade or the one that has 3 bottles of water? So what I want you to do today is write down the title, aerobic respiration, and the date, and have a little think about which one you think may do better. So you probably guessed it would actually be the person or the runner that has Lucozade. That's because it contains not only water, but it also contains sugar. So if you are doing a lot of exercise, you are going to need sugar in the form of glucose to actually perform something we call respiration. Today we are looking at aerobic respiration, and that means respiration in the presence of oxygen. So first of all, I would like you to write down a bullet point or definition for what the word aerobic means. So your body needs a constant supply of energy, and that comes from food. That's why we have to eat regularly and why breakfast is always a great meal to get you started for the rest of the day. So glucose from that digested food comes obviously from carbohydrates. So glucose is a form of sugar. That is where our energy comes from. When that glucose actually reacts with the oxygen that we are breathing in all the time, it releases something called energy. Energy is used by our body for warmth, so to keep us nice and toasty, not only in the winter, but all year round. And it's also used by every single cell in our body to grow, repair itself, and also for us to move around. So the chemical reaction that uses oxygen to transfer energy from glucose to your cells is called aerobic respiration. So what I want you to do now, I want you to use this information and just add some more information to that original sentence or bullet point that you first wrote for a definition for aerobic respiration. So we know that respiration is a chemical reaction that produces energy. So in this case, we're looking at aerobic respiration, which uses oxygen. So the equation for this is glucose plus oxygen. That forms carbon dioxide and water, and of course, energy to fuel our bodies. So the glucose is coming from your food, from your digestive system. The oxygen is coming from your respiration system when we breathe in. The carbon dioxide is one of the waste products, so it's a byproduct of respiration. We are also exhaling, so breathing out water, that's the moisture in our mouth. And we are also making energy, which is the useful product. So carbon dioxide and water are actually just byproducts of this chemical reaction. Can you now write down the equation for aerobic respiration? So you probably guessed that athletes require lots and lots of energy to run a massive race. A marathon is about 26 miles. So eating pasta and things like that will give them a large amount of carbohydrate and a very large amount of glucose. So that is why before a massive race, athletes will often eat things like pasta. So I now want you to go to YouTube and watch the Screaming Jelly Baby video. This is not for the faint-hearted. In fact, if it was at the cinema, it would be an 18. There's quite a horrific scene in it for the Jelly Baby. So I hope this doesn't upset anyone. So I hope that video didn't upset anyone too much. Obviously, we have still got other jelly babies. It's children that are still alive and well. So, our next activity is true or false. So, I want you to read these questions. And then in your books, I just want you to write down 1 to 7 in your margin. And then F for false or T for true. And then see if you got them right. So, what cells might need more energy? You can probably guess the cell on the right-hand side is a sperm cell. Looks a bit like a tadpole. And the cell on the left-hand side is one of your muscle cells. So you probably guessed that a muscle cell uses lots and lots of glucose for movement, activity and exercise. You also probably guessed that a sperm cell needs lots and lots of energy to swim. Actually, a sperm cell swims the equivalent of swimming the ocean or the Pacific Ocean from LA to Tahiti. So although it's only 18 centimetres in real terms, in actual fact, that is the equivalent of us swimming about 4,000 miles. So respiration occurs in an organelle. That is an organ inside our cell called a mitochondria. Can you please write that word down in your book and state what it is? I now want you to read these keywords and then match them to the statements on the right hand side and write these down in your books. Right everyone, I now want you to go to YouTube again and watch our burning food video to see how much energy is released from things like crisps and wotsits and digestives. And then I want you to go back to show my homework and complete the very short quiz. That is the end of today's lesson. Well done, everyone. Woo!
Hello Year 8, we are going to do another experiment today. Thanks for joining us. This experiment is all about burning food. So we're still thinking about respiration and how your body gets this energy from food. We're going to have a look at a couple different types of food. We've got some wotsits, we've got twiglets, we've got some digestive biscuits, and we've got some cream crackers. What we're going to do is show how much energy there is in each of these 4 foods, and we're going to do that by burning them. First things first, I want you to write some results as we do this practical. So think about how you are going to draw a table. Get your books and draw a table please for me now that has these 4 types of food in the table. Pause the video, have a go and start back up when you're ready.
So you should now have a table that looks like this. So in our first column, we have our independent variable. So that's our type of food. Wotsits, twiglets, digestives, crackers. That's what we're changing. And that's what we're going to then measure the amount of energy given off. So that's our dependent variable in our second column there. So make a hypothesis. Which one of these do you think is going to give off the most energy? What do you think, Miss?
Oh, I think the digestives might surprise us.
Okay, I'm going to go for the wotsits.
Right, let's get started. So we've made our predictions. I reckon digestives are going to have quite a lot of energy. Miss has gone for wotsits, and we are going to test. Sorry, that's my thing. We are going to test the amount of energy that's given off. Now, I'd like you to fill out your table as we go, but the problem with this experiment is it's what's called subjective and qualitative. That means that we're just going to look at it and you have to describe it in the best way that you can. I think I would probably go for low, medium or high. If you can think of a better way to describe it, then please go ahead, but try to fill out some results. Let's do the wotsits first.
See if there's any colour changes in flames, anything else that you might want to observe.
What I'm going to do is tilt the Bunsen burner so that we don't get a lot of burnt wotsit falling into the Bunsen burner and potentially damaging it. So wotsits first.
Oh, so red, orange flame there.
Yeah, a bit of a colour change of the flame there. The wotsit is blackening.
A lot of energy coming off from that, Miss.
I'm going to take it out of the flame and see if it still burns on its own. Yeah, now that is all the fuel from the wotsit keeping that flame going.
Remember, that's one Whatsit. So imagine how much energy is in a bag of Whatsits.
Still
Wow.
burning. Still burning. There's still finding energy to burn in there. And
Okay.
now it's the turn of the Twiglet. Twiglet here. Again, we're going to tilt that Bunsen burner, see what we get.
Oh, red.
Ooh. Flame colour again. It's changing. I'm going to take this out of the flame and see if it continues to burn on its own. It does. I'd say in comparison to the Whatsit,
Not quite as much, is it, miss?
not quite as much, although it's picking up now. I think the Whatsit was a bit more convincing there. And it's gone out faster as well. So that was our Twiglet. And now it is the digestive's turn. And to make this a fair test, we have tried to get the same amount of digestive, roughly. To make this a really, really fair test, we would be weighing out and doing this by mass. But for now, this will be okay. Let's pop the digestive in there. We've got very orange flame.
Yeah.
Oh. Hang on.
Oh.
It's a very crumbly biscuit.
Oh.
Like firework. Oh.
And by fireworks night, we might be back in school.
Now, taking that out of the flame,
It's a slow burner, this one.
it is a slow burner.
So maybe this is giving off energy over time.
Ah, it's giving off the energy in a different way. It is still going. That slow release of energy there with the digestive. You can see there is a bit of unburnt section in the middle there.
So maybe crisps are a quick provider of energy, whereas something like a digestive is more of a long-term energy supply.
And last but not least is the cracker. Again, we've got a bit of that orange flame showing up there.
Ready, purple.
It's a bit more reluctant to catch fire, this cracker. Let's let it burn. Oh, quite a nice amount of energy actually in that cracker.
Slightly bigger piece, that, wasn't it, miss?
Slightly bigger piece, not 100% a fair test, but you can evaluate that to yourselves. Actually, quite a lot of energy coming off here in this cracker.
Rivaling the Whatsit.
A really good flame there. I'm going to let you guys decide at home if you think that was the same as the Whatsit, more or less. And you can write that in your tables. And it's still burning. Is it a bigger piece though? A little bit. Still burning.
And that's why you'd obviously want to go on to repeat this, wouldn't you, miss?
You would. You want to repeat this experiment. I want you to think about how you can improve it. We've already talked about a couple of improvements here. I would be weighing these out and doing them at exactly the same mass. And keeping them in the Bunsen flame for the same amount of time.
Any way you could measure the temperatures, miss?
That's a really good question, miss. There is a way that you can improve this experiment, because what we've done at the moment is a qualitative experiment, which means that there are no numbers behind it. We're just looking at it and we're thinking, is it a lot of energy or is it not that much energy? There's a way to improve this, and you can do this experiment in a slightly different way. What you could do is get yourself a boiling tube with some water in it and make sure it is the same volume of water between each of the 4 boiling tubes. Record your starting temperature. Now, this water is straight from the tap, so it is sitting at about 24 degrees. What you can then do is use your burning food. Should we do it now, miss? If we were to burn a piece of food, we can use the energy given off by that food. I'm not going to burn it properly because I am holding this boiling tube. Use the energy given off by that food to record how much it heats up that water. And that would be a test in which we could use the data, because then we've got some numbers to work from, and that would be called a quantitative test, because we can put some numbers behind it. That is a different way of doing that practical. Okay, so as we mentioned before, This type of test is qualitative. There are no numbers behind it. As we mentioned before, this type of test is qualitative. There is no data behind it, no numbers. But these are the rough results that we got. We think Wotsits and crackers had a high amount of energy. We think digestives were probably our lowest, but as we saw, it was taking a long time to burn, so maybe it is a slower release of energy. And Twiglets were somewhere in the middle as a medium. We did also make some additional observations that is always worth noting down if you see them. So we wrote down our flame colours as well. We got some really pretty flame colours there. Really deep red-orange for the Wotsits and crackers and an orange for the Twiglets and digestives. Well done, guys. Thanks for joining us on our practical. Okay, Year 8, we have got a brilliant experiment for you here. This is known as the Screaming Jelly Baby, and we are going to find out why this is our victim today. That lovely scream there from Jelly Baby. Now, we are going to have a look at exactly how much energy is in this poor victim of a Jelly Baby. And we're going to do that by burning this Jelly Baby and using a lot of the oxygen in the air and in this chemical here, which is called potassium chlorate. Now, anything 8 has got lots of oxygen in it, and this is a really strong oxidizer. So think back to your respiration. What happens in respiration? You have got the glucose in your body reacting with oxygen, and that gives off our carbon dioxide and water, and that's how our body releases energy. So we are going to heat up this potassium chlorate to get it nice and energized, ready for our reaction. And then our sorry victim is going to go for a dip.
So as you can see, Miss, at the bottom, it is starting to melt already.
Oh yeah.
Oh no, not going to kill me, Miss Moore.
I am. I really am.
Shall we put him feet first or head first, Miss?
I think feet first for maximum time.
No, stop.
It's evil laughing there. Just
Oh, nearly melted, Miss.
Melted. Once we pop, what should we give him a name?
Yeah, go on.
Oh, Bert, Bruce.
Bruce.
Anyway, you decide a name at home. Give us your names. Email us your Jelly Baby names.
Rest in peace, Bert. No. Ah. Oh, he's struggling, everyone. Here we go.
And there we can see. Amazing reaction there. Sorry, Bert. R.I.P. And that is the Screaming Jelly Baby.